I'm sorry, I snorted on my video. Let me start over. I can pretend that people are listening. It's much easier than being in class and people really aren't listening, but oh well. Your loss. Okay. So, I just want to go over some stuff from Chapter 2 and go over the questions. And so far in Chapter 1, Price kind of introduced you to data models, difference between raster and vector, all kinds of data types, shape files, images, coverages. And then she talked a little about data storage and the hierarchy of a featured data set. She talked about the difference between a GDB, a personal file geodatabase, and an MDB, a personal geodatabase. And then she went over some concepts of scale really briefly and accuracy and precision. So that was kind of the gist of Chapter 1. Chapter 2, she talks about scale of measurement. She also calls this data type. So sometimes data type means whether it's raster or vector. Sometimes data type means the scale of the measurement. So you really have to look at the question to know what she's talking about. So she introduces this idea of nominal data, categorical data, and remember sometimes ordinal data fits in the categorical data. And some people put ordinal data in the numeric data. So I think that's what you were thinking of for the third type. And then in numeric data, that can be divided into ratio or interval, and again, ordinal, just depending on whose textbook you're looking at. Then she goes over the different ways that you symbolize each of those data types, because they all have to be symbolized to be accurate in a different manner. And then she goes over in that chapter how to classify data, whether you're using Jenks or equal interval. And then with exercise 2, you're going to practice this stuff from Chapter 1 and 2, plus you're going to create data that you zip your own geodatabase, import data, and zip and share that with me. So this week you're going to give me your entire geodatabase plus your maps so that I can make sure that we can share data back and forth. Okay, let's see. One thing she might have talked about a little bit was the modified areal unit problem, or MAUP. And this is when you have a large physical area, like a large polygon like Arizona, having more visual impact than a small polygon like New Hampshire. So when you map those, that big mass of one color has way more impact. And so you can really see that with the, I think this is the 2004 election map. That's the famous red state, blue state map. And when you look at this, whatever way the country voted, or the state voted, so if they were predominantly Republican, the entire state area is colored red. If they were predominantly Democrat, the entire state area was colored blue. And you get this real powerful red state, blue state, and this fueled a lot of news reports that said, well, the country is overwhelmingly Republican. You can look at this map, you can see that. And people said, well, wait a minute, let's look at it by county. And so even when, this doesn't show as well as it does on the screen, sorry about that, but even when you look at it by county, you get predominantly a red country. So one of the things to think about is the idea of normalizing data. And this will often fix that modified areal unit problem, not always, but sometimes. So in this chapter, she brings up a little bit about normalizing data, and the key to normalizing data is that you have to divide the field by the whole value that it's part of, okay? So maybe it's clear if I say, if you have a field that says population of women in a state, you can divide that by the total population in the state, and you would get a percentage of women in that state as compared to other states. Or you could divide the population of the women in the state by the area of the state, and it would tell you if you have a lot of crowding of women or not. I don't know. You could divide the number of crimes in Portland by all the crimes in Oregon, right? So you've got that Portland is a part of Oregon, and the crimes in Portland are part of all the crimes in Oregon, so you can divide that. And then you could even do a burglary in Portland by all the crimes in Portland. So then you'd get a percent of the burglaries that are in Portland. You can't divide the women in Oregon by all the divorces in Oregon, because the population of women may not be part of the total divorced population. Now, if you have a column that says number of women divorced, and you have a column that says number of women, then you can do the divorced by the number of women, because you could say what percent of women are divorced. But you cannot divide. I had people divide farms by trailers to get the percent of farm. Well, that means not, you can do that in ArcGIS, but you haven't made a valid normalization. Okay, so when you take the red state, blue state map, and you divide the number of votes for each side, Republican or Democrat, by the total population that voted, then you get a much more accurate picture of the election, which is really a purple country. It was almost, I think, 50% to 49% to 51% was the total vote. And it was not overwhelmingly one side or the other. But the way that easy maps are made, it sure does support that idea of mapping. So she talks about normalizing. Things that are already normalized are data that is a rate, an average, or a mean. Okay? So if you get average bushels of wheat per county, that's already normalized. You can't divide average bushels of wheat by the total area, because you've normalized a normalized. Okay? Yeah. Statistically you can, but you really have to know what you're doing and understand why you're doing it that way. Crime rate. Any word with rate in it's already been normalized. Average age has been normalized. Mean income, all of that's been normalized, so you wouldn't normalize those columns. One of the very first question that she asked on the exercises was about uncertainty. Am I right? Am I in the right chapter? The review questions, yeah. Which I have looked and looked. Does anybody ever find anything that she talked about, that uncertainty question? About the 1 to 20,000, 1 to the scale? Yeah, me neither. I have looked and looked, and I have never found a reference to it. But it's kind of there. Yeah. If you understand scale, you can figure it out. And we'll talk about that in a minute. But horizontal accuracy is something that you may be asked at some point to put that on your map. What is the horizontal accuracy of the data that you collected? And so there is a national mapping standard that says no more than 10% of your XY coordinates on a map have to be be off this certain tolerance. So what that means, let's say you're mapping the location of electrical poles, right? You have a map of electrical poles. Somebody supposedly who does data random checking would go out and physically look at your poles and then look at your map, and if more than 10% of those poles are not within this tolerance on your map, then you don't have an accurate map. And so the horizontal accuracy, so that means kind of where it is in that XY coordinate, depends on the scale of the map. So if I have a map that's really zoomed out, my horizontal accuracy has more leniency, right? I can be within 50 feet plus or minus. If I have a really small scale map and I'm really zoomed in, then my horizontal accuracy has to be less. So for example, let's say I'm working on an engineering scale map of 1 to 2,000, and my tolerance then has to be within 50 inches. And so if I multiply that 0.02 by the 2,000, that means every point that they check has to be within plus or minus 40 feet. So I have a 40-foot tolerance that would make my map accurate. So if my map comes in at 39, they measure 10, they measure 100 polls and 90 of them come in at 39 or less, then I have a horizontal accuracy on my map. So she doesn't ask about that, but I know that you'll see that on maps. They'll talk about that horizontal accuracy. So the first question on the exam was this one, or on the summary questions was, I'll try to read it here. And I will not score this one unless you got it, and then you can have some extra here. A 1 to 20 million scale map of the U.S. displays the interstate with a line symbol that's 3.4 points wide. And now on your map, when you print it, there are 72 points to an inch. And so it says, what is the uncertainty, right? So the uncertainty is if I were to reproduce the width of that line on the surface of the earth, that road would be 14 miles wide. Okay? So in order to get the road to even show up at that scale, I have to really increase the true horizontal accuracy of that road. And I got that by just doing the math here between how many points to an inch and how many points wide was the road. And it shows me that the road was 0.0477 inches. And if I multiply that by the scale, then I get 14.9 miles. So on most maps, you've got to have some generalization, right? Because you would not be able to see the road line if you were actually trying to meet that horizontal accuracy. So often the horizontal accuracy is related to what is the focus of the map, right? So if I'm trying to show the location of dams on a map with a point, my road might be big enough so you can help navigate by that, but my points for the dam locations would need to be accurate, and I really wouldn't be measuring the space of the point, just the location. So that was, and I guess you could have figured that out, but I found it kind of tricky. I don't know what she was going for that. Okay, so this first one, she says types of data state if they're nominal, categorical, ordinal, interval, or ratio. She means scale of measurement, but she doesn't say that. So how about bushels of wheat? Anybody want to do that one? John Paul, what you got for bushels of wheat? What would you choose? So here's the trick with this. Because she doesn't really, she should show you the attribute table, right? So if you saw a number, so if you look at the county, and let's say there's a bunch of counties, and the field says B of wheat, bushels of wheat, and then there would be a number, 50,000, 20,000, 30,000. You're mapping that number, okay? And could you have 0 bushels of wheat in a county? Sure. So then it's numerical and it's a ratio. So you have to kind of think beyond the word and think about what the data type would look like. So on an exam, I'll give you the attribute table so that you can actually look at the data itself. So Derek, you want a field vegetation type? And you can pass. What'd you say? Categorical, perfect. How about pH, James? Can you have 0 pH? Okay, so numeric is right. Interval, it's the third one. It's interval. Okay. Let's see, Colin, average daily maximum temperature. Yep, because you can't have no temperature or 0 temperature. Okay. Oh, this got pixelated funny. Let's see. Pam, what do you think about number of voters in a district? So you look at the attribute, it says 50,000, 20,000. No, the ratio, because the 0 means the ratio is a real number that you can actually do math with. Yes? Elevation, temperature, and pH. If you memorize those 3 are interval, The rest of them you don't have to think about. Everything else would be ratio. Yeah, exactly. Exactly. Let's see. Any of these? How about parcel ID number? What do you think, Taylor? No. Nominal, that ID number. It's a tricky thing. It's like a name. It's like the FID in the yeah. Okay? So I'll put this up there, but this messes people up. So make sure you take a look at that. Okay. How are you going to map these? You know, and when you have the exam, you're going to have, it's going to be open book. So you can try this, right? And see which one works. Okay, so if I have precipitation, so I want to show inches of rainfall across Oregon, am I going to use a single symbol, a graduated color, or a unique value? What do you think? Graduated color, right, right. How about geologic unit? Limestone, granite. Yep, unique symbol, right, right. Yeah. How about just showing rivers? Single symbol or just feature, right? It defaults to feature. Now, if I wanted to show the discharge of the river, right? If I had a field called discharge, then I would maybe try the graduated color. And if there was a field that said ranking for transportation, 1, 3, and 5, I don't know why I skipped, but I did, then I would do maybe graduated color again, or I could even do unique value, right? So pink is, light pink is low river traffic, dark red is high river traffic. So with a lot of these, you have to, again, it would be really helpful to see the attribute table to see what it is that you're actually symbolizing in here, okay? Normalized or not, so here's the key word. Average would not be. Median would not be. Rate would not be. The rest of them could all be normalized. Okay? Let's see. La la la. Oh, a trick question. Did anybody think this was a trick question? Okay, how was your trickly answer? Yeah, so probably, you know, incrementally there might be a little bit more space because you've got more, but in, you know, as far as filling up your database, because you're right, they're not saving the data, they're just saving the symbology information, right? So she was being tricky with that. We talked about this a little bit the other day. So there's two situations, and the key situation here is, let's see, creates a doc and emails it to a friend. So the map document is your MXD, right? There's nothing in this that says she sent him the data, right? So I don't know if she sent the data along. I get MXDs for students all the time. They just send me the MXD and I don't get any data. And it's like, okay, cute MXD, but there's nothing on here. So he says he can't open it. And if she did send the data, she probably didn't send relative pathways. And if he doesn't know that, she shouldn't be sending him data anyway, is my thought on this one. He should know to go look and reset it, and then he should tell her, hey. The second one is they're all connecting to a server, and she probably did set relative pathways that said, look on my desktop or look in my folder, and it should be over there. Yeah. She just, yeah. She just leaves it as the default. Yeah. Right. Okay, so naming files, folders, and documents or field names. What can you not have? No spaces, no special characters. The only special character you can have is an underscore, right? And you cannot start anything with a number. So that's why population 2000 is always pop underscore 2000 instead of pop 2000. Instead of 2000 pop, right? It will break on you. And this can go all the way back to the name of your flash drive, right? If you have spaces in that, eventually, especially when you start working with analysis and raster data, you can get into a lot of problems with the data not being found. I'm taking a database class, and right now, the way that a lot of databases are, come on, you can do it. There you go. A lot of databases are designed, field names would be with a capital, like let's say river discharge. They would no underscore. So in a lot of databases, they don't use the underscore. They would say the first word is capitalized, the second word where we would put an underscore, the next letter is capitalized, and that has a name that is going to be on my exam, but I can't remember it yet, that style. But I was looking in GIS databases, and they tend to use the underscore more than this method. So, and I don't know why that is, but I don't know that the other is wrong. In fact, this saves you a character. Field names can only be 13 characters, so that underscore takes up information sometimes. So I may start transitioning to this as I do that. I don't know. Okay. Thematic raster and an image raster. Anybody feel okay about answering that one? Okay. So you can think of an image raster as being a photo or a satellite image, and they do the RGB or stretched. And then the thematic rasters is a lot like categorical maps, right? They're around some theme that would be temperature, land use, vegetation, something like that you would see that. Yeah, that's pretty good. And what does that pesky red exclamation point mean? Right. And so you'll probably struggle with that off and on a lot. Some people just get it, and I don't know why they don't struggle like most of us struggle with finding our data and making sure we know where it is. ArcGIS has now set up, this is fairly new, and they did not inform me that they did this. I wanted a personal email. They set up a default geodatabase, and so now when you do stuff, it will often just go right to the default geodatabase without telling you. I mean, you used to have to set the location. So you can get really kind of in the zone and start creating, and it's putting it on the N drive here if you're working here, not on my flash drive, and I go home and it's not there. Or it's putting it, if I'm working on my home computer, it's sticking it into the default geodatabase on the home computer. I thought I set it up to put it on my flash drive, and it didn't. But there's a sort of a fix for that we'll talk about next week, where you can set the geodatabase where you want it to go, and it will most always put it there, but it's a good idea to check every time you save something, make sure you know where it's going. Okay. All right. And I don't know if this was part of Chapter 2, but it's a part, when I've been to a couple conferences with employers, and one of the things they always talk about is that, you know, they will have new employees send them an MXD with no data, or not know where the data is. So, you know, this data management and understanding where things are is really critical. But the ArcMap, this thing, this little icon down here that is the globe. So right now when I'm looking at ArcMap, I am only looking at a really tiny window now. I'm only looking at an interface that lets me pull data. So right now this data is being pulled from my flash drive, and I can pull data from the R drive, I can pull data from the internet, and look at it, symbolize it, work with it, make a map. but the data is not in this MXD. It's only the link to the data. So you have to really make sure that you're understanding that this MXD is just a window that's used to create maps to symbolize your data and has all of these tools and objects that you can use to do other things. All right, so it's a drop-down, is it a GUI interface? Is that right? Somebody know what that means? GUI interface? Yeah. So when I first took ArcGIS a while back, and I didn't finish the course, it's because none of this existed. Everything was command line. So everything was coded. If I wanted to open a file, I had to type in this long code that said, you know, go to this directory, open this file, show it in this size window. And yeah, that was not fun. Do you remember that? Did you do that one? You didn't take it that long. It wasn't that long ago. It's like 15 years ago. And so it's changed that much. It was like, oh my God, I can't do this. So, so this is really nice, but it really is only the interface. So much for that.